Hi, my name is Uma Chandrasekharan. This is my video for towards the course project for machine learning for product managers. Um, for the problem that was listed, um, I view given that it was a prediction of electrical energy output, I chose the regression modeling task. And again, for this data set, the features I used was temperature, pressure, humidity, vacuum to predict the electrical energy output. I used the Google AutoML platform to train and deploy my model and test my model. Um, so based on the Google platform, I used the four different parameters to predict. I used the training set. I used the default Google AutoML. Split of data is 80% of the data is used for training set, 10% is for validation, and 10% for test set, and that's the system that I used. Uh, and so for that model training and testing, the evaluation metrics that I received were MAE was 2.309, the unit was megawatts, versus root mean square was 3.046. The two important metrics typically for a regression model. Looks like so it looked like the error. I mean, both MAE and root mean square were pretty. The smaller the value, the better it is. It's not zero, but it's not bad. And I did analyze the different features, and based on the data set we provided, looked like the temperature and vacuum were the main contributors for had had more weight or more importance towards the model than humidity versus pressure. Now, and then once the model was deployed, the model by itself, and by default, when you choose the regression model and go to Google AutoML, the objective that it is trained to is usually towards a root mean square error. Uh, Keeping those default parameters, once I deployed the model, these were the average or default stats that was used. And for this kind of stats, the prediction result was the output energy, the electrical energy output was around 454, almost around 455 megawatts. And the confidence interval was quite tight as well. And then I chose to use one some value within the data set to again test my model. Based on these different numbers, the actual P output was 429.69. However, our model predicted something very close. The error was around 1 megawatt. It was around 430. And again, the 95% confidence interval was around 200 versus 458. So this was good. So the next time I chose the same data set, and rather this time instead of using the default root mean square error as the training optimization objective, I chose MAE to be the optimization objective. So as we all are aware, MAE typically ignores outliers, and it's much better for close-knit data. And I chose this just to see for this data set, does the prediction change? Again, when this and again, I chose the random data split available at Google AutoML. Again, it was 80% training set, 10% validation, and 10% test set. And for this time around, the MAE was 2.2. Compared to last time was 2.3. This time it was 2.2. And root mean square also decreased. It was 2.9. So looked like this model was performing a lot better than the other model. Slightly better than the other model. Again, the feature importance didn't change that much. Temperature and vacuum were major contributors. And then for this model, the default statistics, the average statistics for them, again, the prediction was 455.13, which is slightly again, very close to what was predicted, similar to what was predicted in the prior model, except the difference was the confidence interval. The prediction interval was very wide in this case. It varied anywhere from 0 to 610. Now, again, as I mentioned previously in the prior model, I used a certain set of variables that was to test if test the how the model if the model was predicting correctly, and I used the same parameters the last time, except that last time there was a 1 degree, 1 megawatt difference between the baseline versus the predicted result. This time I felt like the results were much closer. It was around 0.5 megawatt difference, although again, the prediction interval is quite wide. Now, based on the prediction interval is so the question is, for this data set, what's better, a root mean square error or MAE? And I think MAE is a better suited evaluation metric, only because we, on an average, just need an average electrical energy output. We don't need huge. We don't need to penalize large outliers or large errors. So I think MAE is a much better evaluation metric for our case, and that's how I evaluated my model. Thank you so much.